Number 16, simplify. A is 49 to the negative 3/2 power. The first thing that I'm going to do is take care of this one. The negative is the, means to take everything to the denominator. So I'm going to have 1 over 49 to the 3/2 power. The next thing that I'm going to rewrite this a little bit, I know that 2 is a root. Roots grow in the ground, so the root is on the bottom. So this is really like the square root of 49, and then when I'm done, I will cube it. All right, so now we're going to have 1 over. The square root of 49 is going to be 7, and it will be 7 to the 3rd power. So now we're going to have 7 times 7 is 49, and then 49 times 7, 343. So your answer is going to be 1 over 343. Woo, 343 for that one. Accidentally pressed a button. Okay, B is 1,000 to the 5/3 power. Again, roots grow in the ground, so the 3 is going to be the root. So if I want to rewrite this, this is the cube root of 1,000, and then when I'm done with that, I will take it to the 5th power. So the cube root of 1,000 would be what times what times what gives me 1,000. That's going to be 10, and then we need 10 to the 5th power. So 10 to the 5th power means 10 times 10 times 10 times 10 times 10, which will be 1 and 5 zeros. 1, 2, 3, 4, 5 zeros. And so my answer would be 100,000. Number 17, find the intercepts. We finally get to use our calculator on this one. It says to find the intercepts, that means the x and the y-intercept, so we want to find both of them. I'm going to find the y-intercept first because I don't even need my calculator for that one. If I plug in 0 for the x's, I will get -4. So 0, -4 will be my intercept for sure. Okay, now I get to get my calculator out and graph it. When I graph it, I'm going to get something that looks like that. Actually, that should hit down a little bit farther. So this was my y-intercept, which I already found. And then my x-intercept, I'm going to use the 0 feature on my calculator. Remember, we're going to go to 0. We'll type the graph in, and then we'll do second calc. We'll choose 0. We'll need to pick a left bound and a right bound. And after I do that, my 0 should end up being 1.263. Very important that you have to be accurate to 3 decimal places if you would like full credit for this problem. Okay, number 18, in order for a company to break even in the manufacture and sale of a certain item, the revenue R for selling X items must equal the cost C of producing X items. If the two formulas are given for cost and revenue, find the number of items that must be produced and sold for the company to break even. So first of all, we want to find the number of items. So I'm going to find the number of items. We are looking for an X value because it did tell us that it's X items. All right. If we want to break even, it says the revenue must equal the cost. So I am going to set the revenue equal to the cost on this one. So 5.5 square root x plus 10,000 equals 3.29x. All right, so without having to solve this, what we are really going to be doing is looking for the point of intersection. Where do those two equal each other? Instead of solving that algebraically, we can do it this way instead. Okay, so we're looking for the point of intersection. So I'm going to go ahead and graph this. You are going to need to play with the window. The window that I ended up getting to work was the x-min was 0. The x-max I set is 5,000. My y-min was 0, and my y-max ended up being 15,000. And the way that I chose that, I probably picked my y-max first because I noticed if I plugged 0 in here, my intercept would be 10,000, so I knew I needed something bigger than that to figure out what's going on. So when I graphed that, I got a picture. When I used that window, I got a picture that looked something like that. So I'm looking for this point of intersection, and if you use the point of intersection feature on your calculator, you'll get 3133.087. That will be the x value, and 10307.857 will be your y value. Okay, but it asks me for the number of items. So the x value is the number of items. We can't sell a part of an item, so you could really either put 3133 or 3134 would both be acceptable as your answers for that one. Okay, number 19. Let f of x equal a piecewise function. We're going to find f of 6 first of all. So 6 is a number that is bigger than 4, so I'm going to put it into the first one. So 3 times 6 minus 2, that will be 18 minus 2, which gives me 16. The second one, f of 2, is a number that's smaller than 4, so I'm going to use the second equation. So I'll have 5 over 2 squared, and 5 over 2 squared is 5/4. And then the third one, I just have to think about this a little bit. The square root of x always has to be a positive number, so no matter what, it's going to be positive. But since this negative is out here, I'm taking the opposite of a positive number, so this answer will always be negative. So if I look at my choices, x is less than or equal to 4, all the negative values fall in that range, so I'm going to be using 5 over x squared. So now I'm going to plug negative square root of x in for my x, and when I do that, the negative when I square it becomes a positive, and the square root of x when I square it becomes x squared. So I'll get 5 over x squared will be my answer. Excuse me, 5 over x will be my answer on that one. Okay, number 20 is asking me to find the domain of f of x equals 5 over x squared minus x minus 72. And we get to use our calculator on this one, but I'm going to caution you about just using the calculator because you might make a little mistake. So I'm going to do both. Okay, so for this one, if I graph it, I will get, I'm going to get an asymptote at 9. I'm going to get an asymptote at negative 8, and then the graph goes in between, doesn't quite touch. Something like that, something like that, something like that. So I noticed that x can't be two different values where those asymptotes occur, but sometimes if you trace, you can't tell for sure. So we are going to go a little old-fashioned here to find it out. So we're going to take x squared minus x minus 72. We're going to factor it. That will factor as x minus 9 and x plus 8. And I can see on that one, if either of these values would equal 0, it will make the fraction undefined. So when x equals 9, the fraction will be undefined, and when x equals negative 8, the fraction will be undefined. So my domain is going to be anything between negative infinity until I get to negative 8, and then negative 8 to 9, and then 9 to infinity. One thing that I want to be careful of is I'm not going to use brackets on this case because x cannot equal 9 and it cannot equal negative 8.